So today we're going to do a little bit of Algebra 1 review. Today we're going to learn how to solve systems of linear equations by graphing. Now you're going to do this again in Algebra 2 next year. However, in addition to solving linear equations, you're going to have to also solve nonlinear, like where a parabola and a line intersect, or where two circles intersect. And that will have different solutions. For linear solutions, we're going to graph the line, and then where the two lines intersect is going to be our solution. So we can have three different scenarios. We can either have one solution, which is going to be the point of intersection. If the lines are parallel when we graph them, then they will never intersect, and that's going to mean that there is no solution. If we graph them and it turns into the exact same line, then that's when our solution is going to be all real numbers, or some Algebra 1 courses described it as infinitely many solutions. So let's go ahead and do 4 examples and try to find the solution when we graph. Now, the other 2 techniques, we are going to cover those on Thursday and Friday. They will be solving by substitution and solving by elimination. The problem with solving by graphing is you have to be very precise when you're graphing your lines. If you're not using a coordinate plane like this or graph paper, it may be hard to find the point of intersection. But all of the notes have a graph, so we can go ahead and graph these correctly. So when we graph lines, you can either choose to put them into slope-intercept form. And remember, slope-intercept form is y equals mx plus b, where m is your slope. Remember, slope is defined as rise over run. And the b in this is our y-intercept. This is going to be our beginning point that we graph. Now, the other way that you can also graph these lines is by finding the x and the y-intercepts. You could plug in zeros. But today I'm just going to put them into y equals mx plus b form, because that's what we already learned how to do when we were talking about parallel and perpendicular lines. So I'm going to go ahead and do the top equation in red. So I'm going to take x plus y equals 6. I'm going to solve it for y. My goal is to get y by itself. So I'm going to subtract the x. And now I'm left with y equals negative x plus 6. So this is my y-intercept, or my b. This is going to be my slope. I assume it to be a negative 1. So my slope is going to be negative 1 over 1. So I'm going to rise and run. For my rise, because it's negative, I'm going to go down. For my run, I'm always going to go to the right. Now, you could go up and left. One of the movements needs to be negative. So let me go ahead and place my first point on the y-axis at positive 6. So I'm going to go ahead and count. 1, 2, 3, 4, 5, 6. That is my y-intercept. From that point, I'm going to move my slope, my rise and run. I'm going to go down 1 and to the right 1, and then put my next point. You can keep repeating this rise and run to get a nice precise line. Now, because you guys are doing this in Notability, you could actually just hold down your stylus and you could get a nice straight line. I'm going to go ahead and connect my points. And this is the graph of that first equation. I'm now going to graph the second equation in blue. X minus y equals 4. I need to get y by itself. Negative y equals negative x plus 4. I now need to divide everything by negative 1 because I do not want a negative y. So negative x divided by negative 1 gives me positive x. And then positive 4 divided by negative 1 is negative 4. So for this one, this is my y-intercept. My slope here is a 1. So 1 and 1. So I'm going to go up. My rise will be rise up 1, and then I'm going to run to the right 1 for my run. So I'm going to put my first point on -4 on the y-axis. And then from there, I'm going to go up 1 and to the right 1. And then I can keep adding points if you want. And then notice my point of intersection here is going to be this order pair, 5, 1. So the solution to this system of equations is the order pair 5, 1. It is the point where the two lines intersect. All right, the next example, we're going to do exactly the same thing. I'm going to graph the red one in blue, but first, red. We're going to go ahead and put it into y equals mx plus b form first. So let me subtract 2x. Y equals -2x plus 2. I'm going to go ahead and graph it. My slope, I can change that -2 into 2 over 1. So I'm going to go down 2 for my rise, and then I'm going to run to the right 1. So I'm going to put my first point on +2, and then from there, go down 2 and to the right 1. Now, you could also go up and left. It doesn't really matter. So I'll go ahead and connect my points and graph my line. Now I'm going to do the same thing for the second one, but I'm going to do it in blue. X minus y equals 4. Subtract x. -y equals -x plus 4. Divide everything by -1. And y equals x minus 4. Same equation as before. So my first point is going to be on -4. My slope is 1 over 1. So up 1 and to the right 1. So right here is my first point on -4. Then rise 1, run 1. And then you can see your point of intersection is going to be that order pair, +2, -2. And that is your solution. Both of these were examples of one solution answers. So for the next one, same thing. Let me do the top one in red. X minus 3y equals 2. Subtract x. -3y equals -x plus 2. Divide everything by -3. And this ends up giving me y equals +1/3 x minus 2/3. Now, I'm going to go ahead and rearrange the second one first before I graph this one, because I just want to show you what we're going to end up getting. So then the second one I'm going to do in blue. 3y minus 1 equals x. Going to add 1. 3y equals x plus 1. Divide everything by 3. And y equals 1/3 x plus 1/3. Notice the slopes are the same. And when we covered the chapter on parallel and perpendicular lines, we learned that parallel lines have the same slope. So these lines are going to be parallel. So when you have parallel lines, the answer to this is going to be no solution, because our graphs will never intersect. And I'm going to graph them to show you that it's going to be no solution. Now this one's a little tricky because I've got a fraction for my y-intercept. So for the blue one, my slope here, I'm going to go up 1 and to the right 3. For the red one, same thing. I'm going to go up 1 and to the right 3. But I'm starting at -2/3. So -2/3, again, because my graph is, I'm going to make it go by ones, -2/3 could be right around here. So if I rise 1 and run 3, I'm here. So this could be my line for the first one. And then for the blue one, I'm starting at positive 1/3, rising 1 and running 3. And notice my graphs are gonna run side by side, but never intersect because they're parallel. So this is why these two equations have no solution, because they never intersect. So for this one, let's rearrange them both. So 2x minus y equals 1. I need to get y by itself, so I'm going to subtract 2x. And now I divide everything by -1 because I don't want a negative y. So y equals 2x minus 1. Let me go ahead and rearrange the second one. So my second one is 6x minus 3y equals 3. Subtract the 6x. Negative 3y equals negative 6x plus 3. Divide everything by -3. And notice my two equations are exactly the same. So when the equations turn into the same equation, then it's going to be all real numbers because it's exactly the same line. Now, again, some Algebra 1 courses say that it's infinitely many solutions. Either way, when we cover all real numbers in Algebra 2, you're going to be learning something called interval notation. So if you ever see negative infinity to positive infinity, that's how you can write all real numbers. Another symbol for all real numbers is you do a capital R and then you add another line down to it. So I'll go ahead and graph this equation. I only have to graph it once because it's the same line. So again, here my slope is 2/1. So I'm going to go up 2 and to the right 1, starting at -1. So when I zoom in here, -1, up 2, and to the right 1. And then I just graph it once because it's exactly the same line for both equations. So every single number is the same, and that's why it's infinitely many solutions, or all real numbers. And that is it for your review of solving a system by graphing. So we have 3 scenarios, either one order pair, making it one solution, no solution when the lines are parallel, and all real numbers or infinitely many when it's exactly the same line.